Hey everyone, I'm going to show you guys how to make a regular triangular pyramid. That is a pyramid which has 4 sides to it, including the bottom, in which all sides are the same length. I'm making this video because I didn't really find other tutorials that really did this for me, so once I figured it out, it turned out to be really simple, and I just wanted to show you guys how to do it with this particular method. So, it doesn't take too long. We're going to start at the top plane, and we're just going to quickly draw a triangle around our origin. And then we're going to add 2 center lines that go from any 2 points of the triangle to the opposite sides. You can even do 3 if you want, but it's really not necessary. Then we're going to add some relations to this. So the first relation that will probably already be there because of the way that we lay down the lines will be this horizontal relation for the bottom line of the triangle. Next, you want all of these lines to be equal because it's a normal triangle. We want both of these center lines to also be equal. And then the endpoints of each of these center lines need to be the midpoint of the side at which they're connecting to. Also, these center lines will be coincident with the origin. And then we are good to go. The last thing we need to fully define this sketch is a dimension for one of the sides. I'm going to use 19 millimeters. When I did this the first time, I was creating a 4-sided pyramid-shaped die, and so it was pretty small, 19 millimeters. And this is the driving dimension for this entire sketch, for this entire part, actually. Now we're almost done with this sketch. It is fully defined, but one thing we're going to do for future reference will be to add a driven dimension to one of these center lines. Now these center lines effectively are the height of the triangle, and so this length of that center line is the height of a triangle and of all of the other triangles, and that'll be important. All right, we are now done with this sketch. I'm going to call it our reference. Actually, I'm just going to call it our driving triangle, since it will be driving this entire shape. The next thing we need is a reference for how high the triangle will be. So to do that, I'm going to go to our right plane, create a sketch there, and just draw a line from the origin vertically straight up. So now this will be our height reference, but to define how high it is based on the already existing geometry of the triangle, our driving triangle, we're going to actually create a construction line here that connects to the top of this line and to the closest side of the triangle. And a relation you're going to need to add here is actually to make sure to select that point in this line and select pierce. Lastly, for this sketch, we will be adding a dimension to this construction line, and we're going to set it equal to that driven dimension that we added to our original sketch. So you can see we actually now have a fully defined sketch with a line. Now, to understand why this is being set equal to that, realize, and I'm sure you probably already have, but realize that when this is going to be a full pyramid, there will be a triangular face that will go from this point to that point to that point there. And so this line is actually going to form the height of that triangle. And since all of the triangles are the same size and same shape, that will be equal to the height of this triangle. And that's essentially what we just did. The reason that I use an equals equation, equals dimension, rather than a relationship between this line and this line of equals, is that Solidworks gets wonky because these lines are not on planes that are parallel to one another. for reasons that I don't fully understand. And so this just circumnavigates any issues. Sometimes I've gotten it to work that way, but this is just, you don't have to worry about it. So I'm going to call this sketch our height reference. And then we have one more sketch to make, but before we make it, we actually need to add a plane to make it on. So we're going to go to Insert, Reference Geometry, Plane. And this plane will essentially be the plane that one of the faces, one of the other faces of the pyramid will be on. So you can choose any of the three sides of this triangle. I'm going to choose this side that we are already working on. And that line of that triangle, our driving triangle, will form the first reference for our plane to be coincident with that line. And our plane will also be coincident with the top of our pyramid, which is also going to be the top of this line. Our plane is now fully defined. I'm going to hide it, and then I'm going to make a sketch on it. This will be our last sketch, and it's by far the simplest. We're just going to take a line and we're going to create our triangle again, going from these points to essentially draw the face that will be there. I'm going to say good. Now you'll notice this isn't fully defined. That's just because some of these relations aren't automatically added. So you'll want to take this point and that point, make them coincident with one another. Sometimes these don't get added automatically too. If it's not fully defined, it's probably because one or all of these points are not actually defined as being coincident with those points. So just go in and add those. That's it now. It's being completely driven by those other things, and then we're going to, I'm just going to call this sketch our driven triangle. We actually have everything we need now. So the last step, we're going to go to Features, and we're going to choose a lofted, boss, or base. For our profiles, we're going to choose the driving triangle and the driven triangle. And you can see that's all we actually need. The height reference, though, is driving our driven triangle at that top point, so it's very important. And there we go. Now we have a triangular pyramid that is normal. So all of these sides are the same size and the same shape. Something I like to do, it's not necessary, but in this feature you can come down to centerline parameters. You can actually select the height reference. And the reason I do this, because while it doesn't need that for the lofted base itself, it includes it thus, that sketch underneath this. And so for organization purposes, I like to put it in there because we need it either way. And now this sketch is being completely driven by this value. So if I decided I needed to make this a different size, that's all there is to it. And it makes the entire shape bigger. And then you can do whatever you need with this. Like I said, I made a die, so then I added numbers and things like that to it to make it useful. But there it is. I hope this was helpful to someone, because I definitely could have used this when I was trying to figure it out.